using a blue conductor as a neutral in a 12/4 cable is a violation of the National Electrical Code. The code mandates that the white conductor, or a grey conductor, be used as the neutral or grounded conductor in a circuit. This standardization is crucial for safety and consistency across electrical installations. The blue conductor in a 12/4 cable is intended for other purposes, typically as a phase conductor in a multi-wire branch circuit or as a traveler wire in a 3-way or 4-way switch circuit. Here's why using a blue wire as a neutral is problematic and contrary to established electrical practices. Firstly, it creates confusion for anyone working on the electrical system in the future. Electricians rely on color coding to quickly identify the function of each conductor. The consistent use of white for neutral and other colors for phase conductors allows for safe and efficient troubleshooting and maintenance. If the blue wire is used as a neutral, it deviates from this standard, potentially leading to incorrect assumptions and dangerous situations. Secondly, it increases the risk of electrical shock. If someone expects the white wire to be the neutral but encounters a blue wire being used as neutral, they might inadvertently touch what they believe is a safe, grounded conductor, but it could actually be carrying current if the neutral connection is broken or improperly made. This could result in a severe electrical shock. Thirdly, it violates specific requirements in the National Electrical Code concerning the identification of conductors. The NEC, in Section 200.6, outlines the requirements for the identification of grounded conductors. It states that the grounded conductor must be identified by a continuous white or grey color. This requirement is not just a recommendation, but a mandatory rule to ensure safety and proper electrical system operation. Fourthly, it may not meet inspection standards. Electrical inspectors are trained to look for code compliance, and the use of a blue wire as a neutral is a clear violation. An installation using the blue wire in this manner would likely fail inspection, requiring correction before the electrical system can be approved for use. Fifthly, it can complicate future modifications and repairs. If the electrical system needs to be altered or repaired, the non-standard use of the blue wire as a neutral can create significant problems. Electricians may have difficulty tracing circuits and identifying conductors, leading to errors and delays. It is important to adhere to the National Electrical Code for several reasons. Firstly, safety. The NEC is designed to protect people and property from electrical hazards. Compliance with the code ensures that electrical installations are safe and reliable. Secondly, standardization. The NEC provides a consistent set of rules and guidelines for electrical work, making it easier for electricians, inspectors, and other professionals to communicate and collaborate. Thirdly, legal compliance. In most jurisdictions, electrical work must comply with the NEC. Failure to comply can result in fines, penalties, and even legal action. Fourthly, insurance requirements. Insurance companies may require compliance with the NEC as a condition of coverage. If an electrical installation does not meet code requirements, it could void the insurance policy. To properly wire two circuits using a 12/4 cable, the white wire is used as the neutral for the first circuit, and a separate cable must be used for the second circuit to provide its own dedicated neutral. Alternatively, a 12/2 cable with ground can be run for the second circuit, ensuring each circuit has its own identified neutral conductor. The NEC addresses multi-wire branch circuits in Article 210. A multi-wire branch circuit shares a common neutral, but it must be properly installed to avoid overloading the neutral conductor. This typically involves using a 2-pole circuit breaker that disconnects both ungrounded conductors simultaneously, or ensuring that the neutral is rated to handle the maximum unbalanced load. In the scenario described, each circuit must have its own dedicated neutral conductor to comply with the NEC. If the neutral conductor is undersized or improperly installed, it can lead to overheating, voltage drops, and other problems. In addition, it's also important to consider the ampacity of the 12-gauge wire. According to NEC Table 310.16, 12-gauge copper wire is typically rated for 20 amps when used in residential wiring. It is crucial not to exceed this ampacity rating to prevent overheating and potential fire hazards. When running multiple circuits, ensure that each circuit is properly protected by a circuit breaker of the appropriate size. For 12-gauge wire, this would typically be a 20-amp circuit breaker. It is also important to label the circuit breakers clearly to indicate which circuits they control. The importance of proper grounding cannot be overstated. Grounding provides a low impedance path for fault current to return to the source, tripping the circuit breaker and energizing the circuit. This protects against electrical shock and reduces the risk of fire. All electrical equipment and appliances should be properly grounded in accordance with the NEC. Electrical safety is paramount, and any deviation from established codes and standards can have serious consequences. Always consult with a qualified electrician and adhere to the NEC to ensure that electrical installations are safe and compliant. Using the proper tools and equipment is also crucial for electrical work. When working with wires, use insulated tools to prevent electrical shock. Use a wire stripper to remove insulation from wires without damaging the conductors. Use a multimeter to test circuits for voltage and continuity. Always turn off the power before working on electrical circuits, and verify that the power is off using a multimeter. Additionally, wear appropriate personal protective equipment, such as safety glasses and gloves to protect against electrical hazards. When making connections, use approved connectors and terminals. Ensure that connections are tight and secure to prevent loose connections, which can cause overheating and arcing. Follow the manufacturer's instructions for installing electrical equipment and appliances. When running wires, avoid sharp bends and kinks, which can damage the insulation and reduce the ampacity of the wire. Protect wires from physical damage by using conduit or other protective measures. Keep electrical panels and equipment clear of obstructions to allow for easy access and maintenance. Regularly inspect electrical systems for signs of damage or wear, and address any problems promptly. If you are not comfortable working on electrical circuits, hire a qualified electrician to do the work. Electrical work can be dangerous, and it is important to have the knowledge and skills necessary to do the job safely. By following these guidelines and adhering to the National Electrical Code, it is possible to create safe and reliable electrical installations. Remember that electrical safety is everyone's responsibility, and taking the time to do the job right can prevent accidents and save lives. In summary, the National Electrical Code specifies the use of white or grey-coloured wires for neutral conductors for very important safety reasons. Using any other colour like blue violates these rules, which introduces confusion, increases risk of electrical shock, and could mean failing any electrical inspection. Always ensure to check with a licensed electrician to make sure that all work complies with NEC standards. The NEC exists to safeguard property and lives, and it should be followed at all times.